2026 A-Level Combined Mathematics Paper 1 Part B, question number 14, Part B. Part A of this same question was discussed in a previous video, link in the top right. Part B of this question has to do with derivatives and optimization. The question says, as shown in the figure, the boundary of the shaded region S, which is this region right here, consists of two concentric circular arcs of radii r meters and 2 r meters that are each subtending an angle of theta radians at the center O, and two straight line segments that when extended pass through the center O. So here we can see the region S is covered by this arc, and these two straight lines. Now given that they then say the area of the shaded region S is given to be 81 meters squared, and with this information we are to show that the perimeter P meters of the shaded region S is given by P equals 2 times r plus 81 divided by r for r greater than 0, and also are asked to find the values of r and theta such that the perimeter P is minimum. Now to start off with this question, let's consider the shaded region S. Now looking at the diagram, we can see this shaded region S right here is equal to the difference in areas of this large sector right here and this small sector right here. If we take the large sector's area and subtract from that the small sector's area, we should get the area S. So according to that, we can write the equation area of S equals the area of this large sector minus the area of this small sector. Now considering these two sectors, we can see the large sector has radius of 2r and it also has an angle of theta, and according to that the area is going to be equal to half times the radius squared times theta, which is half times 2r squared times theta, and then you have to subtract from that the area of the small sector, which is equal to half times radius squared, which is r, so r squared times the angle, which is theta. So then we can see we get area of S equals half times 2r squared times theta minus half times r squared theta. Now in here what we're going to do is to substitute in the area they gave us of 81 meters squared. So doing so, we can see on the left hand side we get 81, and on the right hand side we have half times 4 times r squared times theta minus a half times r squared times theta. So here what I'm going to do is to subtract this 4r squared and r squared, and then we get 3 times r squared times theta divided by 2. Now into here what I'm going to do is to take this expression and rearrange it to get theta in terms of r squared. The reason I'm doing this is because I can see later in the question somewhere we will have to substitute r's instead of theta. So therefore if I rearrange this, we can see we get theta equals 2 times 81 divided by 3 divided by r squared. So we can divide by 3r squared, and right now I know we can simplify some of this, but I'm going to leave this as it is and call this equation number 1. Now with that, let's try and figure out the equation for the perimeter P. Now looking at the shaded region S, we can see the perimeter of this shaded region is equal to this length plus this arc length plus this length plus this other arc length. Now these two lengths are both equal to r. This length is equal to r and this length is also equal to r. So we have 2 r's, and in addition to that we also have this arc length and this arc length. Now considering these two, since the radius here is r and here is 2r, and both of these have area angle subtended as theta, we can see the angle here is going to give us this length being equal to r theta and this length being equal to 2r times theta. So we have r theta, 2r theta, r and r as the 4 components of our perimeter. So going down, we can say that the perimeter P is equal to r plus the other r plus the r theta arc length plus 2r theta arc length, and simplifying we can see we have 2r plus r theta and 2r theta for a total of 3r theta. Now into here, since in the original expression for P they don't have any thetas, I'm going to substitute equation number 1 to get rid of all of the thetas. So doing so, we can see if we substitute in equation number 1, we will get P equals 2r plus 3r times the value of theta, which is equal to 2 times 81 divided by 3r squared. And here we can see this 3 and this 3 cancel, and one of these r's and one of these r's cancel, leaving us with P equals 2R plus 2 times 81 divided by R. And factoring out the 2, we can see we get P equals 2 times R plus 81 divided by R. And this is exactly the expression that we had in the question. So now finally we can say this is valid for R greater than 0, and then we can end this thing right here. So we can write P equals 2 times R plus 81 divided by R for R greater than 0, and finish with the first part of the question. Now moving on to the second part says find the values of R and theta such that P is minimum. Now if we consider the graph here, this graph is going to look something like this. If we plot P on the y-axis and R on the x-axis, we are going to get a graph that looks something like this. Now in this graph, the value of R that gives us the minimum value of P is going to be this value of R right here. And at this point we can see we have a turning point in the graph of P versus R. Now according to that, what we need to do in order to find this value of R corresponding to the lowest value of P is to simply take the derivative of this expression in order to find the turning point of this graph. So for this, what we need to do is to take this expression and try to find dP by dr, and then when we equate that to 0, we will get the turning point in this graph. So if we consider taking dP by dr, we can see we have a constant term of 2 which I'll keep on the outside, and on the inside we have r, which when we take the derivative is equal to 1, and we have 81 divided by r, which is 81 times r to the minus 1, which when we take the derivative is going to be equal to minus 1 times 81 times r to the power of minus 1, which is minus 2. And therefore we get minus 81 divided by r squared. So here we can substitute minus 81 divided by r squared. So that is the expression of our derivative. So if I erase this bit right here, we can write 1 minus 81 divided by r squared. Now from this we can say stationary points occur when dP by dr equals 0. And according to that, a local minimum or local maximum will occur when dP by dr is equal to 0. So considering this, we substitute in the actual expression of dP by dr, we get 2 times 1 minus 81 divided by r squared equals 0, and rearranging we can see we can get 1 equals 81 divided by r squared, and thus r squared equals 81, and thus r equals 9. And here we need to say r cannot be equal to negative 9 since r greater than 0. So we can say r equals 9, and we can say because r greater than 0. Now we also need to find the corresponding angle of theta to this, and we also need to show that this turning point is a local minimum. Now I'm going to do the angle theta one first, and I'm going to do that by using this expression right here. So taking this, I can see from equation number 1, we get theta equals 2 times 81 divided by 3 times r squared, which is going to be equal to 9 squared, and therefore we get theta equals 2 times 81 divided by 3 times 9 squared, which is also 81, and cancelling those two, we get theta equals 2 over 3. So with this, we have found the corresponding r and theta. Now all we need to do is to make sure that this value of r and theta give us a minimum value of the perimeter and not a maximum value of the perimeter. So for this, what we'll do is to try and see if on the left hand side of our graph, the graph is going down, and on the right hand side, the graph is going up. Because if that's the case, then the turning point will be a local minimum. So for this, we need to take values of r that are less than 9 and values of r that are greater than 9. Now, in this case, I'm actually going to cheat, okay? Usually in these questions, actually pretty much always in these questions, they give you equations where you do in fact get the local minimum or the local maximum. And due to that, we don't actually have to check. We can just make the statement that the graph is decreasing before the actual value of r equals 9 and is increasing for the values of r greater than 9. We can just assume that that's the case and just write it in full confidence even though we didn't actually check it. So due to that, I am going to assume that the graph is going down, and thus dP by dr is negative, dr less than 0, for r's that are less than the value of r, which is as a turning point, which is r equals 9. And I'm also going to assume that dp by dr is positive, so the graph is going up for r which is greater than 9. So I'm going to directly write this down as a statement even though I don't know whether it's true or not. And I'm going to say dp by dr is less than 0 for r's less than the target value, which is going to be r equals 9, so less than 9, and dp by dr is greater than 0 for r's greater than the target value, which is r greater than 9. Now according to that, we can say therefore r equals 9 is a minimum, and with that we can say therefore minimum value of p that we wanted, minimum value of p occurs when, and we can write the two values of r and theta, which are r equals 9 and theta equals 2/3. So you can write when r equals 9, comma, theta equals 2/3, and with that we are done with this question. Now finally, let's go up and discuss the marks awarded for this question. So at the start of the question, when you find the area of S and equate with this, simplify, substitute, and get this equation for theta in terms of r, you get 5 marks. After that, when you then write down the equation as perimeter, like so, as 2r plus 3r theta, you get 5 marks. And when you substitute in the value from equation number 1 into there, simplify, and get the equation that they gave us, you get another 5 marks. Now after that, when you take the derivative, get this value, and then equate that to 0, simplify, and get r equals 9. For getting r equals 9, you get 5 marks. And then when you take equation number 1, substitute, and get the corresponding value of theta. For getting that value of theta, you get another 5 marks. And finally, when you make the argument that since the derivative is negative for all the values of r less than the correct value, and it's positive for all the values of r after that, the graph is going down and then turning up again, and therefore at the turning point we have a minimum, and from that when you conclude that the values of r equals 9 and theta equals 2/3 give a minimum p, you get a final 5 marks. And that is the end of this question. So I hope you enjoyed. If you have any feedback or questions, post them in the comments down below. Thank you for watching, and goodbye.